me, I want Dad to see my pictures first. Here's the B-17. That's a B-24. And here's the P-38. And here's the P-47. Now see if I'm right, Jet. Wingspan, 41 feet. Patent Whitney, 2,000 horsepower engine. A full-bladed, 12-foot, 2-inch propeller. I mean clock.
I don't see any propeller.
Yeah, of course you don't. It's turning over 2,700 RPM.
Oh, I see. And what's this?
That's a turbo supercharger. It's one I designed myself. It's a lot better than the one in the P-47. The air in my turbo comes through this duct.
Jimmy, why don't you duck?
Not duck, duct. Science talk. Anyway, you gotta have a turbo supercharger to take a P-47 upstairs. Don't you know anything about airplanes?
Jimmy knows his airplane. He's not kidding when he says that the high-altitude performance of the P-47 depends on that turbo packing air into the carburetor. The turbo does for the 47 what the pilot's oxygen system does for the pilot. Keeps the ship flying high at fighting efficiency. The turbo in your 47 is simple in operation, much simpler than Jimmy. The actual compressing of air is done back here in the rotor. Exhaust gases turn the bucket wheel, which drives the impeller of the compressor. The waste gates in the exhaust system control the speed of the rotor by opening and closing, and thus directing more or less gas against the bucket wheel. The waste gates are operated by a regulator. The regulator, in turn, is controlled by the pilot when he changes the control setting on the quadrant. When you establish a control setting, the regulator will automatically operate the waste gates to maintain manifold pressure. As you increase altitude and decreased atmospheric pressure causes engine power to drop off, the waste gates gradually close. More exhaust gas is directed against the bucket wheel to make it rotate faster and compress more air. Now another indicator becomes important, the turbo overspeed warning light. When your P-47 nears its critical altitude, the rotor will reach about 18,000 RPM, and this light will blink. When the light stays on steadily, you have reached the maximum allowable speed of the turbo under normal conditions, 18,250 RPM. Anything that moves has a speed or stress limit. That goes for the wheel and impeller of the turbo. They're not designed to hold up long at speeds over 18,250 RPM. The blinking light is a warning. The steady light means you've reached the critical speed of the turbo. Above critical altitude, you reduce manifold pressure to keep the warning light blinking while you continue to climb. Now, let's watch the controls in relation to a climb. The turbo light begins to flicker. Turbo speed is increasing. When turbo speed reaches 18,250 RPM, the light comes on steady. The pilot reduces power to the point at which the light flickers. He keeps reducing power as may be necessary to keep the light flickering throughout his climb. That's all he has to remember. Keep that light blinking. In P-47D5s and subsequent models, the water injection system gives war emergency power for limited periods, increasing horsepower and rate of climb beyond military power limits. With water injection, you'll build up approximately 56 inches of manifold pressure and develop 2,300 horsepower. Water injection will increase your speed about 20 miles an hour. Save water injection for emergency. Think of it just the way you do your guns. When you start aerobatics in the P-47, Remember when you were taking a trainer through these same maneuvers. The P-47 is a bigger, faster, and heavier ship. But you put a 47 through its paces just about as you did your AT-6. There are exceptions, of course, and they're important. In the 47, you avoid inverted flight, except for the few seconds necessary to perform a given maneuver, since inverted flight starves the engine for oil. Snap rolls are not permitted. And in practicing dives, you pay particular attention to speed and altitude. The P-47 can reach a speed of 500 miles per hour indicated from an altitude of 10,000 feet or below. That's to remind you pilots with strong left arms that in the 47 you can lose about 10,000 feet in attaining 500 miles an hour indicated. Better go up higher, around 20,000 feet or above, if you're going to keep, say, a 10,000-foot margin between you and terra firma. At higher altitudes, where the air is thinner, dives should be held to lower indicated airspeeds. As the dive chart on your instrument panel will tell you, a safe diving speed of 30 to 35,000 feet is 250 indicated airspeed. At 25 to 30,000, it's 300 indicated. At 20 to 25,000, it's 350. At 15 to 20,000, it's 400. At 10 to 15,000, it's 450. And at sea level to 10,000 feet, it's 500, which you'll remember is not recommended for a steep dive in training. These are speeds at which you'll find handling characteristics of the P-47 to be normal. The P-47 can be pushed into speeds of compressibility where a breakdown of airflow occurs. And under such conditions, you may experience a temporary loss of control until you've dropped to denser air. When you dive the P-47, your cowl flaps should be closed, oil and intercooler shutters in neutral. Your plane is trimmed for level flight. When you come back on the throttle, you'll do it gradually, bringing the throttle back just enough to keep from overboosting the engine. In your first dive, take it easy. Get on to this airplane's diving characteristics. You do the loop in the 47 just the way you did in your training plane. In the slow roll, as in all your aerobatics, give yourself plenty of altitude. Put the nose on a point and keep her rolling. The Immelman. A good one takes plenty of power and speed. To spin the 47, stall it and then kick it into the spin as you would any other airplane. To recover, you'll apply full opposite rudder, neutralize elevators, pull ailerons against the spin, and use power to speed recovery. One turn is all that's recommended. One practice spin is all you need in your training. In the half roll or split S, you'll pick up speed fast when you start your dive. Always do this maneuver with plenty of altitude and always with power off, spelled O-double-F. For skeptical pilots, we draw a diagram. Here is an airplane to fight in. With all its speed and performance, with all its fighting punch, the Thunderbolt handles the way you like it. Smooth, quick, sure. The aerobatics you do in the P-47 are a prelude to combat. When you're flying the Thunderbolt, you've got an airplane strapped to your pants that's designed to chase the enemy out of the sky. It takes two to do the job, the airplane and the pilot. To pilots of the P-47, good hunting.